Okay, I'm on page 270. And maybe what we should do first is review a little bit of what we know. If we're dealing with sine, and usually what I find to think about, so that I don't get too confused when I'm dealing with it, when I'm talking about inverse functions, I just try to remember that the sine is everything is going to happen in that range. And then if I'm doing inverse, I plug the values in for y and figure out what the values on the x would be. If I'm doing the regular sine, then these are going to be my independent variable values. Rather than think of it as that, where it goes kind of this way down, right? And then try to remember the inverse function. So what I'm doing is if I do, this is what I'm telling you, is if I'm doing sine of pi over 4, then I'm going to get square root of 2 over 2. But if I'm doing sine inverse of square root of 2 over 2, I'm going to go backwards. So if I'm doing sine inverses, then my input values are the values along here. 1/2 square root of 2 over 2, square root of 3 over 2, and 1, and then so on down here. But I'm only going to think about it as values between minus pi over 2 and pi over 2. Do you understand what I'm telling you? Don't try to graph that inverse function where you have -1 to +1 down here, and then minus pi over 2 to plus pi over 2 vertical, and try to remember it that way. And I'll just draw these out, and then as we do them, maybe it will become clearer what I'm trying to tell you. So -1 +1. This is y equals sine x. And this one I'm going to go y equals cosine x. And what we're going to do is we're going pi over 2. And this one goes this way. And then tangent I'm going to think about tangent. And this goes on and on up forever, and then at pi over 4 and a minus pi over 4. What this is, just for reference, this is 1, -1. So at minus pi over 4, you're going to get -1. At plus pi over 4, you're going to get a +1. Then what we'll do is I'll do some problems, and then we will refer back to this thing to try to pick up the answers if we can't see it. So I'm going to do 14 on page 270. And here it says y equals tangent inverse of 1. Well, if you go back here, 1 is here, and pi over 4 is what I get. See, technically this should be on the x-axis, but I'm not going to learn this thing as an inverse function. I'm just going to learn it as a function and then say that what I'm inputting here is my vertical number. And I'm going to get here not x, but I'm going to get x rather than, you see what I'm doing? I'm inputting 1 that is associated with pi over 4. Rather than putting plus 1 down here and have my inverse function and then try to figure out where it is. I'm just saying this ordered pair right here for this is pi over 4 on the x and 1 on the y. But when I'm asked this, I'm going to input the y value here and get the x value back here. So the answer is y equals pi over 4. I'm just going to limit the amount of things I have to learn, and I'm just going to know when I do inverse, see, it's the reverse ordered pair. I'm putting this value in and getting this value out on tangent inverse. For straight tangent, I put this value in and get that value out. See, on this function right here, if I put x is pi over 4, I get y is 1. But when I do it this way, tangent inverse, I put 1 in and get pi over 4 out. That's the inverse. Because the inverse is just interchanging the x and y coordinates. So let's look at 16. It says y equals arc tangent of a minus 1. So what I'm going to be doing is I'm going to be putting this minus 1 in, and I'm going to be outputting minus pi over 4.
So the 14, 1, 5 is pi over 4, and then 16 is negative pi over 4. That
Yeah.
makes sense. I forgot about arc tangent.
Arc tangent is like tangent inverse. It's
Oh.
another way of writing tangent inverse.
Okay. Same thing. Gotcha.
Yeah.
All right.
So in 18, y equals cosine inverse of 1/2. So I'm going to go back and I'm going to refer to this. And notice what is it? It's inverse of 1/2. So on this from 0 to pi, what is this value for 1/2 up here? For a vertical of 1/2. Well, the normal ones that we have are pi over 6, right? Pi over 4 and pi over 3. And then 2 pi over 3 and 3 pi over 4. And then 5 pi over 6. Now, which one of these has a positive 1/2? Pi over 3 does, don't it? Okay. But see, what we're doing here is we're saying the cosine inverse. We want the radian measurement that gives us 1/2. That's pi over 6. Correct? y is pi over 6. Because we're taking it from the ordered pair that at pi over 6 we get 1/2. And the inverse function is 1/2 pi over 6. So when it says cosine inverse of 1/2, it wants it this way. Pi over 3. What I wrote pi over 4 here. It's pi over 3. It's just pi over 3. That's where it's 1/2. You see, when we're doing inverses, we're just flipping it around. See what I can. 18 if we do 20. Y equals arc sine of a negative square root of 3 over 2. So on this sine, what value between minus pi over 2 and pi over 2 is this coordinate minus square root of 3 over 2? Negative pi over 3, isn't it? See, this is minus square root of 3 over 2. See, it's a negative square root of 3 over 2 at what? The ordered pair is that we're taking this off of is that at a negative pi over 3, we have a negative square root of 3 over 2. So the arc sine gives me this, minus square root of 3 over 2, and asks me for this. Y equals negative pi over 3. Because, see, it's only defined between, our sine inverse is only defined between pi over 2 and minus pi over 2. No place outside of that.
Where's that? I was trying to find out the arc circle just so I could get the pair, but I didn't.
Oh, and if you're doing the unit circle, then what you do is the sine is defined from here down to there in quadrant 1 and quadrant 4. Square root of 5 pi over 3. No, it's a negative. You don't go the positive, you go the negative. See, it's defined between a minus pi over 2 and a plus pi over 2. See, if you look at your definitions for the sine inverse, cosine inverse, and all of those, back on page 265, says the sine inverse, the domain is from -1 to +1, but the range is from minus pi over 2 to plus pi over 2. If you do a minus 1, you will not get a negative. You will not get a positive. Let's see, I got 3 pi over 2. You will get a negative pi over 2. Because it's defined between here and here. If I do my calculator in degree mode, which is easier probably to, if I go -1, right? If I do sine and I put this mode in degrees, turn it on. Now, and I do a -1. And I would go second sine, so that's sine inverse of a -1. Now, that's not going to give me 270 degrees. It's going to give me a -90 degrees. It's defined from -90 to +90. That's what it's telling you right there. That's what it's telling you right on page, look at that, page 265. It says when you do sine inverse, the interval is from minus pi over 2 or -90 to plus pi over 2, +90. And then cosine inverse goes from -1 to +1, but it's going to go between 0 and 180 if you want to call it that, pi. Because that's where it's a one-to-one function. And that's where they just arbitrarily choose it. And then, you can, it's in quadrant 4. So if I do 22, y equals tangent inverse of a -1. Well, you notice that tangent is defined between a minus pi over 2 and pi over 2. And -1, it's at a negative pi over 4. So the answer to this one, tangent inverse of a -1, is a negative pi over 4. If you use your calculator, you can see that that's what they're going to do. Like if you go second tangent, then you go -1, and I'm in degree mode. So how many degrees is that going to be? Negative pi over 4. Negative 45 degrees.
Yeah.
Negative 45 degrees. It's where it's one-to-one, and it's just an arbitrary definition. You just have to remember that that's where it's at. So 22. So if I go 24, y equals cosine inverse of 1/2. Now I'm going to use this cosine, and what's the angle where I have 1/2? Okay, but if it's in radian measurement, it's going to be, did we have cosine or something? Cosine. Yeah, you had me confused as to what you were talking about.
I was looking at sine, not cosine.
Yeah. So cosine at 1/2, where are you going to be at? Pi over 3? What was it negative? I thought it was a positive 1/2. Dang it. No, was this supposed to be 24? Supposed to be a negative 1/2? Okay. All right. I just wrote it down wrong. So then that would be 2 pi over 3, isn't it? Because the negative 1/2 is 2 pi over 3. So y is 2 pi over 3. Oh, it's 26. Says y equals arc sine of a negative square root of 2 over 2. So we're using this. So where is it a negative square root of 2 over 2? Yeah, minus pi over 4, you're going to have a negative square root of 2 over 2. You're using that unit circle, you're going to have to go, you're going to have to put the 270 as a negative pi over 2, or negative 90 degrees, because it's going to show you 270, and that's going to confuse you. So this one is negative pi over 4. Y equals secant inverse square root of 2. Now, what you have to do with this thing is, unless you happen to know what it is, I'll try it this way. Secant's 1 over cosine, right? So to get the square root of 2, the angle you'd have to have is something that gave you the square root of 2 over 2, right? So if you had, if the cosine is the square root of 2 over 2, and you invert this, and you invert this, and you rationalize the denominator, then what you get is 2 square root of 2 over 2, and these cancel. So it's got to be something that gives you the square root of 2 over 2 for cosine, and it's got to be negative. So what you do is you look at your cosine and you say, where am I going to have a negative square root of 2 over 2? And it's going to be at 3 pi over 4. Because secant's 1 over. Yeah, Corey, did you have a question? Do you have a question, or did you? Or are you stretching? If the other way you can do this problem is you can say this thing is where secant of y equals a negative square root of 2. And secant's 1 over cosine, so 1 over cosine of y equals a negative square root of 2. Then you invert this, cosine y equals negative 1 over square root of 2. And then you have to rationalize it. That is get rid of this thing in the denominator. Minus the square root of 2 over 2. Yeah. So the cosine of y equals a negative square root of 2 over 2. Now you say y is equal to the cosine inverse of a negative square root of 2 over 2. And that y is the y that you're looking for up in this problem right here. If you were putting in a calculator, this is the process you'd have to go through to figure out what you're going to do. Okay, 28 and 30 says y equals arc cotangent of a negative square root of 3. Okay, now when this thing is a negative square root of 3, remember that we talked about it last time, that when you get done and get the answer, it's either going to be you have to add pi or add 180 degrees to your answer, because your calculator doesn't have cotangent inverse. You only have tangent, and we only have tangent back here. So we got to convert cotangent to tangent. So what we do is we say, well, this is the same thing as cotangent of y equals a negative square root of 3, which is the same thing as saying 1 over tangent, because we got to convert it to tangent, is equal to a negative square root of 3. All right. Now, that means that if I invert this, I invert this. So that's tangent of y equals a negative 1 over the square root of 3. Now what I'm going to have to do is rationalize my denominator. And this is a negative square root of 3 over 3. Now what we're going to have to reason out is because we don't know what this is, we got to reason it out this way. We have to say tangent is really sine over cosine. And so where does sine over cosine give me square root of 3 over 3? In the range from minus pi over 2 to pi over 2. Well, it's got to be what? We'll have to have square root of 3 in the denominator and 1 in the numerator. And that's the same thing as kind of reversing back. We'd have to have a combination of 1/2 and the square root of 3 over 2. So what angle gives us 1/2 and the square root of 3 over 2 with a negative?
Oh,
from minus pi over 2 to pi over 2. Okay,
There it's 120 on the.
negative. So it's got to be, what did you say? It's got to be like negative pi over 3, right?
So cosine needs to be square root of 3 over 2. Negative 1 half. Pi over 6.
Yes, negative 30, right? Or negative pi over 6, right? Because sine would go negative 1/2 because it's 0 at 0, and the cosine is going to be square root of 3 over 2. So that would be it. So that's, but now the y is going to have to be minus pi over 6, but we've got to what? Add pi to it. Because we're doing cotangent. So what's that going to be? 5 pi over 6? And that should be our answer. That's what the answer is. And this is pretty darn difficult because it's right at the bottom of your problems in that section. That's what they're going to be. I notice that this falls within the range for cotangent. If you look at cotangent back here says the cotangent inverse has got to be from 0 to pi on page 265. And it's telling you to not use your calculator because if you can figure them out by not using your calculator, then when you use your calculator, you can figure out what the things are. 36. Here it says you want to give the degree measure. So now that we have done these other ones, arc cosine of a negative 1/2. And remember, cosine goes from what? 0 out to pi. So where is it going to be minus 1/2? Pi over 6. But that's how many degrees? Pi, no, pi, not pi over 6. 2 pi over 3. Which is what? 120 degrees. Okay. Now we could do 38. So it's theta arc sine. Now, what is the range there? Minus pi over 2, pi over 2. No, well, I better, why don't I do it degrees? This is supposed to be 0 to 180 because we're doing degrees. This should be minus 90 plus. Well, okay. I'll just minus 90 to 90. So have you got it figured out? Everyone agree? Minus 45 degrees. I can't hear you. What?
Can you just explain why it's minus 45 rather than minus 155?
Because it has to be between minus 90 and plus 90. Because and where that is spelled out is back there on page 265 when it says sine inverse. And notice the interval that it's defined over is minus pi over 2 to pi over 2. Do you see that? That's where it's 1 to 1. Remember, it has to be 1 to 1, and you have to specify the range. And this is just a universal specification, because if you put it in your calculator, you'll get the same thing. So I got this calculator in degree mode, and if I do sine inverse of minus second square root of 2 then it's going to give me minus 45. Even though at what you said it also is that same thing, but it's not. That's beyond the 1 to 1 range that's specified. Okay, 38. Forty says theta equals cosecant inverse of negative 2. Now, what we want to do is we want to change this over so that we can see it in terms of sine and cosine. So this thing can be written this way, right? Cosecant of theta equals minus 2. We're looking for this theta. This is what's given to us. That's what this is telling us. But now, if you write it this way, cosecant is 1 over sine, right? So this is 1 over sine of theta equals minus 2. Now, if you flip that over, so technically we're looking for theta, where the sine of theta is equal to minus 1/2. And the range for cosecant is the same as the range for sine. This one you're looking for from a minus 90 degrees to 90 degrees. This one will give it to you from minus 90 degrees to 90 degrees. If you do sine inverse. If I actually did it in a calculator, then I would do it this way. But what is theta between minus 90 and 90 that results in negative 1/2? What's that? Negative 30 degrees. So the theta that's here is the same theta that results in this. So this is equal to 30 degrees. But to kind of see it, you got to change it around. Does that make sense? What? It's going to be a negative 30. Yeah. Okay, so 42 theta equals cosecant. This one maybe you know it, I don't know. Cosecant's 1 over sine. So sine theta equals minus 1. Where's that going to be? Theta equals negative 90. Right? You see, you understand, Lucas, do you understand what we've been doing?
I am so far behind, I need to look at the class. Please.
James, are you, okay, that's good, that answers. I mean, if enough of you are a little bit in a fog, we can go back and look at that first slide and see that you understand it. James?
Yeah, I'm a little lost, I guess. So I understand 1 over cosine when there's a negative 90. You're just following that the graph that you drew.
Yeah.
Right?
What I'm doing is cosecant, I want to get it written in sine and cosine.
Right.
Because clear back here at the beginning, see these are the inverse functions. And inverse functions are actually associating things on the y-axis with things on the x. It has to be 1 to 1. And that's why you only have this part of that whole sinusoidal curve that goes up and down, because that's not 1 to 1. So anytime you have values between minus 1 and plus 1, they're going to give you sine inverse values that are going to range from minus pi over 2 to pi over 2. And this is just a universal thing. It's in the calculator. I've shown it. That's the way they do it. Or yeah, and then cosine is going to be defined between 0 and pi, or 0 and 180 degrees. And all the values between a plus 1 and minus 1 are going to be associated with values between 0 and pi, or 0 and 180 degrees. And all the values between 1 and minus 1 are going to have associated values between minus pi over 2 and pi over 2, or minus 90 and plus 90. Now, minus 1 and plus 1 has a whole lot of other ones that you go through. But see, it has to be 1 to 1 when you're going backwards. When you're giving it a value here and you're trying to get an angle value, it can only spit you back 1. Well, it's not a 1 to 1 function. But if I just take, for example, the sine function, and if we go pi over 2, pi, 3 pi over 2, and 2 pi, and we go back here the same way. And you go positive 1 here and a negative 1 down here. Well, and we try and graph it. Well, that's kind of not a good portion, is it? what it's going, the sine function is going to start out at 0, right? Go maximum, 0, minimum, 0. When it comes back this way, it goes minimum, 0, maximum, 0. So it's basically looking like this. Now, if I said between 1 and -1, 1/2, tell me the angle that has 1/2, well, what could you get? You could get this one, or this one, or this one, or this one of the ones I plotted, right? Well, what is your calculator? Does a calculator, when you go sine inverse of 1/2, say, well, it could be, you know, 30 degrees, or it could be 30 back from 180, 150 degrees, or it could be, no, it gives you one value. And which value does it give you? It gives you this one, because it is between pi/2 and -pi/2. It has to be functional. Functional says for every input, there can only be one output. And that only occurs when you're going inverse, when you're putting these values in and asking for these values between -pi/2. There's other places that you could do it. You could have designated in this range, right? Or you could designate it in this range, right? They had to pick one. For sine, for y equals sine, they chose it from -pi/2 to pi/2. And then the cosine does what? It goes this way, right? They had to pick something, so they picked it from 0 to pi. And tangent, they picked the one from -pi/2 to pi/2. Is that?
Yeah, it's still kind of like, I'll take a look at it. Just
Yeah.
read through it, sometimes that helps.
Yeah.
If I have a problem, I'm sorry.
Well, we'll look at some more of these things, because what you got to be able to do in order to use your calculator, then you got to be able to, you have to be able to rewrite it so that you can put it in your calculator. And then you got to remember in the cotangent, when you do convert it to tangent inverse, and if it's a negative number, then you got to add 180.
But we should be able to do 1 through 46, the ones we've gone through, if we can understand those.
Yeah.
Keep adding more.
Yeah, and then I'll work some more in class so that we can, talk about it. Lucas?
Videos on your page, are they
Oh.
available?